Welcome to physics class. Today we will learn about force on a current carrying conductor placed in a magnetic field. We have seen in a state experiment that a current carrying conductor produces magnetic field and applies force on the magnetic needle. Ampere suggested that reverse of this should also be true. That is, the magnet must also exert equal and opposite force on the current carrying conductor. Experimentally, this has been found true. Magnetic field produced by a magnet exerts a force on a current carrying conductor and produces motion in it. This can be demonstrated through the following experiment. Activity 13.7. Take a small aluminum rod AB. Using two connecting wires, suspend it horizontally from a stand. Place a strong horseshoe magnet in such a way that rod lies between the two poles with a magnetic field directed upward. For this, put the north pole of the magnet vertically below and the south pole vertically above the aluminum rod. Connect the aluminum rod in series with a battery and a key. You may use the rheostat also. Now pass a current through aluminum rod from end B to A. What do you observe? It is observed that the rod is displaced toward the left. You will notice that the rod gets displaced. Reverse the direction of the current flowing through the rod and observe the direction of its displacement. It is now toward the right. The displacement of the rod in this activity suggests that force is exerted on the current carrying aluminum rod when it is placed in magnetic field. It also suggests that the direction of the force is also reversed when the direction of current through the conductor is reversed. Experiments have shown that the displacement of the rod is largest or the magnitude of the force is the highest when direction of current is at right angles to the direction of the magnetic field. In such a condition, we can use a simple rule to find the direction of the force of a conductor.
This is a TV wire experiment. When we switch on the circuit, the conductor will experience the force in the forward direction, and when we change the polarity of the circuit, the conductor will experience the force in the backward direction, due to which it moves to inside to inverse the magnet, and when we change the polarity, it will move outside from the magnet.
Fleming's left hand rule. According to this rule, stretch the thumb, forefinger, and middle finger of your left hand such that they are mutually perpendicular to each other. If the first finger points in the direction of magnetic field, the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. Now we will discuss the question answers, page number 231. First question, which of the following property of a proton can change while it moves freely in a magnetic field? There may be more than one correct option in this MCQ. Mass, speed, velocity and momentum. So correct answers are C and D. A proton can change its velocity and momentum while it moves freely in a magnetic field. Due to change in the direction of the motion, velocity of the proton, thus momentum, may also change. Page 232, question number 2. In activity 13.7, how do we think the displacement of rod AB will be affected if, first point, current in rod AB is increased? Then, on increasing the current in the rod, displacement of the rod is increased. B point, a stronger horseshoe magnet is used. On using a stronger horseshoe magnet, the displacement of the rod is also increased. Third part, on increasing the length of the rod, means when the length of rod AB is increased, then the displacement of the rod is also increased. Now question number 3. A positively charged particle, alpha particle projected toward the west is deflected towards north by a magnetic field. The direction of magnetic field is towards south, towards east, downward, upward. Correct option is D, upward. Direction of the motion of positively charged alpha particle is the direction of current, that is toward west. Direction of force is the deflection experienced by it is due north. On applying Fleming's left hand rule, the direction of magnetic field is vertically upward. So, correct option is D. Now we will discuss about the electric motor, its principle, construction, working and uses. What is an electric motor? The first electric motor was invented by William Sturgeon in 1832 and successful one was done in 1873. A machine that converts electricity into mechanical energy or motion is known as electric motor. An electric motor is a type of prime mover for a mechanical system. Another definition of electric motor: a motor is a device which converts electrical energy into mechanical energy. Principle of motor: a motor works on the principle that when a rectangular coil is placed in a magnetic field and current is passed through it, a force acts on the coil which rotates it continuously. In other words, electric motor works on the principle that a current carrying conductor placed in a magnetic field experiences a force. Construction of an electric motor. Armature coil. A large number of turns of insulated copper wire wound on iron core in rectangular shape forms an armature coil ABCD. Second part, strong magnets. The armature coil is placed in between two pole pieces N and S, north and south, of a strong magnet. This provides a strong magnetic field. Third part, split ring commutator. It consists of two halves, R1 and R2, of a metallic ring. The ends of the armature coil are connected to the direction of the current in the armature coil. Brushes. Two carbon brushes B1 and V2 are used to press the commutator. Battery. The battery supplies the current to the armature coil. This is all about the construction. Working of electric motor. Current in the coil ABCD enters from the source battery through conducting brush X and flows back to the battery through brush Y. Notice that current in the arm AB of the coil flows from A to B. In arm CD, it flows from C to D, that is opposite to the direction of current through arm AB. On applying Fleming's left-hand rule for the direction of force on a current-carrying conductor in a magnetic field, we find that force acting on arm AB pushes it downwards, while the force acting on arm CD pushes it upward. Thus, the coil and the axle O mounted free to turn about an axis rotate anti-clockwise. At half rotation, Q makes contact with the brush X and P with brush Y. Therefore, the current in the coil gets reversed and flows along the path DCBA, a device that reverses the direction of the flow of current through a circuit is called a commutator. In electric motor, the split rings acts as commutator. The reversal of the current also reverses the direction of force acting on the two arms AB and CD. Thus, arm AB of the coil that was earlier pushed downward is now pushed up, and arm CD previously pushed up is now pushed down. Therefore, the coil and the axle rotate half a turn more in the same direction. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil and to the axle. From this diagram, it is very clear that C1 and C2 are split ring and B1 and B2 are brushes. After half rotation, C2 joins B1 brush and C1 joins B2 brush. So there may be change in the notations what you are using for the splittering and the brushes. You have to draw two diagrams to explain the working of motor in first half and second half, likewise shown here. Uses of electric motor. Motors have a wide variety of uses and are found in car, clocks, drills, fans, fridge, hair dryers, toothbrushes, vacuum cleaners, water pumps, washing machines, hard disk drives, DVD players, electric vehicles, and industrial equipments including the extruders, forklift trucks, lathes, mills, hoists, robots, and winches. On the basis of today's discussion, means this video, you have to answer now these questions on page number 233. First question, state Fleming's left hand rule, we have discussed in this video. Second, also principle of the electric motor. Third, role of split ring in a electric motor. Write these answers in your science notebook. Thank you for watching.